Okay, there are 5 properties we're going to go through to help us be able to simplify expressions, whether they are numerical or algebraic, that'll help us simplify expressions involving exponents. So the first one talks about a power times a power. So we are taking it's a multiplication problem, and when they say a power, they're talking about something like 3 squared is a power. 4 to the 3rd power is a power. So when we're taking a power times a power, is there a kind of like a shortcut we can take? Okay? So I want you to underline this because this is really a big deal. If the bases are the same, this is the only time we can apply this property, is if the bases are the same. So let's look at the algebraic expression right here. X to the m power times x to the n power. What's the base?
X.
X. X is the base in both of those. So the bases are the same. So we're multiplying powers that both have a base of x, and it says what can we do with their exponents? We can what? We can just add them. We can add those 2 exponents together. So x to the m power times x to the n power, this is just total generic algebraic form, becomes x, the base stays the same, to the m plus n power. But can we add m and n? Right now, are they like terms? Not in the algebraic expression we can't, can we? M plus n, they're representing 2 different values. So let's do a problem where we know what x is, and we know what m is, and we know what n is, okay? So we have 3 to the 3rd power times 3 to the 5th power. What would that become? 3 to the 8th power. How do we get that? Add the exponents 3 and 5. So would you do that, please? 3 raised to the expression 3 plus 5. Add their exponents. Because what are those exponents really telling us? What is that 3? And what is that 5 really saying? What's going on? What does 3 to the 3rd power mean? What does 3 to the 5th power mean? Besides putting it into your calculator and getting an answer. What does 3 to the 3rd power mean? Multiplying 3 by itself 3 times. 3 factors of 3. So let's just write that out over here. 3 times 3 times 3. That's our 3 to the 3rd. What does 3 to the 5th mean then? Multiply with 5 factors of 3. So, and then there's a multiplication in between those guys. So there's the multiplication between. So we really have how many total factors of 3?
8.
8, which is 3 plus 5. So instead of having to write it out in this extended form, we can say this means 3 factors of 3. The other one means 5 factors of 3. So when I multiply those guys all together, I have 3 plus 5. I have 8 factors of 3 altogether. Okay. So let's just check this out on our calculator and make sure it works. Okay. I want you to right now in your calculator actually take 3 to the 3rd power times 3 to the 5th power. Put it in just like that. Do you know how to use the power key in your calculators?
No.
Oh, okay. What is the x squared key for? Just a square. Well, then you can only use that one when you want to take something to the 2nd power. Otherwise, your calculator might have an upside down v key. Anybody got that? Mm-hmm. That would mean you take 3. This says raised to a power. 3 times 3 raised to the 8th, not 8th power, 5th power. The answer is that. Some of you might have this key. Anybody got that key?
Yeah.
Okay, that raises to a power. You're saying, I want the base 3. I'm going to raise it to a power. What I want you to fill in that little box is the 3.
And then make sure you press the over arrow so that it gets you back to regular numbers.
Okay? So it doesn't stay up in the power,
So it doesn't stay up in your exponent.
doesn't stay up in the exponent. What did you get?
6,561.
Are you mad, Joe?
No.
Oh, okay, now let's take 3 to the 8th power in your calculators. What's 3 raised to the 8th power? Why do I have some people here without calculators?
No, that was the answer.
3 to the 8th.
3 to the 8th power is the same as 3 to the 3rd times 3 to the 5th, so we're expecting to get the same value, which is 6,561, right?
Yeah.
Okay. So when we are evaluating powers, instead of having to write out all of those factors, we can take that shortcut and add their exponents together and then say that we should get 3 to the 8th. Now, on here, we're just practicing the properties. Tell me though, I know some of you are like, seriously, you want me to take 3 to the 8th power by myself without a calculator? How are you going to do that? Oh,
There's gotta be an easier version.
there's got to be some easy way to do it, isn't there? I wonder what it could be. Because I'm sure you don't want to start at the beginning and go 3 times 3 is 9, and then take that times 3, 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 and then take that times 3. That's a whole lot of multiplication problems, isn't it?
Yeah.
Got another idea, Chloe?
Like things like that, and then what you did.
So in other words, maybe pair some up, is that what you're saying? Pair them up? So I could pair these guys up and say I get 9, and I could pair these guys up and say I get 9. Oh, well there's 4 factors of 3. What is 9 times 9?
81.
81. Oh, how many factors of 3 are left?
4.
Oh, so what should that be?
81.
Oh, so then we could just multiply 81 times 81. Would that be a little bit easier?
Yeah.
6,561.
I know, and just like that, you can do it in your head. 81 times 81 is 6,561. You guys are so amazing.
Thank you.
You are too.
Thank you.
You're welcome.
Okay. So, again, don't fudge at home when I can't keep my eye on you. Don't use your calculator. Come up with strategies that will help you be able to multiply without the calculator. Okay? Okay, let's go on to the next property, which says that we are going to do a power divided by a power. Or in other words, if you see a fraction. Because what does the fraction bar mean? Means divided by. We often say the word over, 3 over 4, but in reality it's 3 divided by 4. So when we have a fraction, or in other words, our numerator and our denominator are powers in this fraction, what can we do? Again, I ask you to underline if the bases are the same. You can only apply this property if the bases are the same. You can't otherwise. And it says, all we gotta do is a subtraction problem then. Instead of adding the exponents this time, we have to subtract. But notice, look at here's our powers, x to the m power divided by x to the n power. What's the base? X, so our answer should have an x as the base. And notice what they did, they took m minus n. Numerator subtract denominator. Does order matter in subtraction? Is 5 take away 3 the same as 3 take away 5?
No.
No. So order does matter in subtraction. So we have to start with the numerator and subtract the denominator's exponent. So in this one we would do 3 to the, turn it down. 3 to the what? What kind of work are we going to show here?
3.
That's what you did.
Okay, seriously, it's not your first day hearing a phone go off.
Sorry.
Redirect. 3 to the what?
3 minus
3 to the 3 minus 5 power. Does it have to go in that order?
Yes.
Yes,
Yeah.
the numerator is 3, the denominator is 5. So it becomes 3 to the what power?
-2.
-2 power. Now, you learned in your SQ3R that if you have a negative power, what's true? It's positive?
No.
What do you mean it's positive? I don't know what you mean by that. Anybody know what 3 to the -2 power is without your calculator?
-6.
-6. Okay.
Oh.
Positive what?
6.
Positive 9.
9.
Positive 9.
You have to take 3 times.
Even, would be like
Be like a decimal.
No.
Is it a nice decimal?
What?
No, it's not a nice decimal. Huh?
It's 1
It's 1/9.
No.
Yes, it's 1/9. I remember that.
You do. -6 to 1/9. Now you changed your mind. You remember, the first thing you remembered was wrong because that was when it was snowing, and then yesterday when the sun came out, it got clear. Okay,
Yeah.
that's good. Okay, so 1/9. Well, let's see if that even works. 3 to the 3rd power means, do this with me. 3 to the 3rd power means 3 factors of 3. 3 to the 5th power means
3 factors of 5.
5 factors of
3.
3. Oh, it's so loose with your words. What can we do when there's no addition or subtraction happening in the fraction? Cancel. Let's go. This is so fun. Go. Go.
Go.
Gone.
Gone.
Everything's gone upstairs. Now what?
2 bottom ones.
Well, what about the upstairs? What am I going to do? Put a 0?
Put a
1.
I'm going to put a 1. Thank you.
Yeah.
And what's downstairs?
9.
Oh, this does equal 1/9. Good thing the sun came out yesterday.
Yeah.
So we're going to be talking about those negative exponents more tomorrow, but this proves why it is 1/9, not -6 or 9 or +6 or whatever else maybe was floating around out there. Okay? So those are the first 2 properties. If I say to you, what property should we apply, you better be able to tell me. If we have a power times the power, what do?
Multiplication.
What's the shortcut for the property? If the bases are the same, a power times a power, we add the exponent. If it's a power divided by a power and the bases are the same, we are going to subtract the exponents. Okay, let's look at the 3rd property that they assumed you knew when you got to me. Power of a power, or in other words, a power being raised to a power. Listen to that. A power raised to a power. How many exponents would be involved? 2. A power raised to another power, there would be 2 exponents involved. So when you have a power being raised to a power, does it say anything about they have to have the same base? No, because there's only one base. It's a base that has already got an exponent on it, and that power is now being raised to another power, or in other words, let's put a box around that, or a circle. X to the m power is being raised to the n power. And what's the shortcut there?
Multiply m and n.
Multiply the exponents, which are m and n. Can we make that 2m or 2n or anything like that? What do you think? Are m and n like terms? No, they were. We could call them both m's if they would have been representing the same thing, or both n's. So notice it becomes x to the m times n power. So what are we going to do for 3 squared? 3 to the 2nd power. That is being raised to the 5th power. So what are we going to do?
3 to the 2 times 5.
I don't want the base to disappear. I want the base to still be there.
3 to the 2 times 5.
3 to the 2 times 5 power. That's right. The base 3 is going to be raised to the powers being multiplied times each other. And 2 times 5 is?
10.
That's good. Okay, let's try that in our calculators and see that it works. want you to put, you have to put it in parentheses, you gotta say, I'm gonna give you a power, so parentheses, 3 squared, close that parenthesis, and then take that to the 5th power. And tell me what the number is this time. I'm sorry, try again.
59,000.
So did I hear it right now?
Yeah.
Okay. Now I want you to take 3 to the 10th power in your calculator. 3 raised to the 10th power. Better get the same thing right, or we didn't simplify it.
59,049.
Wow, we're good. So if we simplify correctly, either way that we input it into our calculator, either way that we do it, we should get the same thing. Because what does 3 squared to the 5th power really mean? What's going on there?
What did you say? I didn't.
What is, oh, what did I just hear?
3 times itself 5 times.
3 times itself 5 times?
I didn't even hear the question.
What does 3 squared raised to the 5th power really mean? You're kind of close, Amber. You guys, you mumble, you say it just quiet enough that just in case you're wrong, nobody hears you. Carson? 3 squared times 5? No. 3 squared raised to the 5th power.
9 times
No.
itself 5 times.
Well, yeah, but what's the other, where did you get 9?
Because 3 squared is 9.
Oh, so we could just do this?
Yes.
3
I don't see
squared,
why not.
3 squared to the 5th power means 3 squared times itself 5 times. 5 factors of 3 squared.
Yes.
Well, now we have a power times a power times a power times a power times a power. What do we do when we have a power times a power with the same base?
Oh.
We add their exponents. Is 2 plus 2 plus 2 plus 2 plus 2 10?
Yes.
Yeah.
Oh. Okay. You gotta get this. You got it?
Yes.
Okay, no, for just that property, a power raised to a power, we said take the exponents times each other, base does not matter in that case. How about the next one where we're taking the power of a product? What does product mean is going on?
Multiplication.
Multiplication. So in other words, there's a multiplication problem, and it'll always be in parentheses when it's being taken to a power. A multiplication problem is happening within the parentheses, and that multiplication problem is being taken to a power. So would you circle that? XY in parentheses means what?
Multiplying.
Multiplying what?
X and
X
Y.
and Y. We have a multiplication problem there, don't we? X is being multiplied by Y, or you could say it vice versa, Y is being multiplied by X. There's our product, and it is being taken to what power?
M.
To the M power. So here's what we're going to do. We're going to raise each factor. What are the factors in that XY? What are the factors in X times Y? X and Y. X is a factor, Y is a factor. The parts of a multiplication problem are called factors. So each factor gets its own power of M. X gets a power of M, Y gets a power of M. So what would we do for 2 times 3, not simplifying within the parentheses right now? How would we apply that property to 2 times 3, and it's going to be raised to the 3rd power? Joe?
2, 3 times
Oh,
3.
what's 2, 3? 23.
2 to the 3.
Third.
3rd power, sorry.
2 to the 3. Okay. 2 to the 3rd power times
3 to the 3rd power.
times 3 to the 3rd power. Can I make that now 5 to the 6th power?
No.
Well, I thought you could add the exponents.
They are all the same base.
Oh, they're not the same base. Yeah, they're not the same base, so we can't do any more simplifying that way. Instead, we would have to say, what is 2 to the third power? Anybody know?
27. No. Hey.
I figured that when you multiply by 2, you didn't even know.
No, I was doing 3 to the 2. Second power. It's
Eight.
A.
It's
A.
Okay, and 3 to the third power is
27.
27, so you really have to take 8 times 27, that's the only shortcut you can take there, isn't it? Okay. That was almost painful. Okay, let's look at this, right here, circle that. They're gonna get this complicated, and they should have been this complicated in your SQ3Rs. And either you faked you knew what you were doing, or you really did, I don't know. We have x to the a power, y to the b power. Is that a product? X to the a, y to the b power. Is that a product? Anybody see an addition sign?
No.
Anybody see a subtraction sign?
No.
Anybody see a fraction bar?
No.
Well, then I think it's a multiplication problem.
Yeah.
Okay, thanks. So what are the factors? No,
A, B, C.
x is a base, y is a base. A, B, C, no.
C.
What are the factors in this problem?
Just C.
X is a base, y is a base, they are not the factors. What is being multiplied?
X A and Y B.
X, A,
Oh, A, X and A, and Y and B.
Yes.
X to the A power is a factor, and y to the b power is a factor. In other words, we could stick a little multiplication dot in here, right there, and we would see that this is a factor, and this is a factor, and we're supposed to give each of them their own exponent, and our exponent in this problem, the power that is being raised to. We have a product of powers, and we have, that's being raised to a power besides. So each of these are going to get that little c on the outside. Notice it's still on the outside, isn't it?
Yes.
Well, now we have to apply the property we just learned before. We have a power to a power. We have a power to a power. What do we do, Joe?
You have to multiply, or you can't multiply. I guess you have to multiply.
You do, but you're like kind of like you don't get real far, do you?
Yeah.
Because a times c is
AC.
AC. It's as good as that.
Yeah.
We don't know what a is. We don't know what c is. We can't really multiply. So we have x to the a power times y, or x to the ac power times y to the bc power. Each of them. So sometimes you're going to apply more than one property to get to what you want. So let's try that with our 2 to the third power times 3 to the second power. And we're going to take that product to the fourth power. So what's the first thing we have to do? I know you can take 2 to the third power, but I don't care. I don't want you to do that. Joe?
You have to get 2 to the third power to 2 to the third power times 4 to the power.
Not times 4, but to the,
Fourth power.
like that, yeah. You give 2 to the third power, the first factor, 2 to the third power, gets raised to the fourth power. And then, what's our other factor? 3 to the second power, we gotta put it in parentheses because it's a power, and that's gonna get raised to the fourth power. But are we done? No, what property do we have to apply now? What property? Name the property for me. Power to a power. 2 to the third power raised to the fourth power. Power to a power. What do we do with those powers? Multiply them. So we're going to have 2 to the 3 times 4 power
12.
times 3 to the 2 times 4 power. And this is going to become 2 to the 12th times 3 to the 8th. And right now we don't care what 2 to the 12th power is and 3 to the 8th. We we're just practicing being able to simplify before we have to use some other strategies to multiply. Okay, questions? Yeah, one more.
Let's get it done.
This is actually a pretty easy one. A fraction raised to a power, or in other words, you have the power of a quotient. That's what we call a division problem. So a fraction raised to a power. So our fraction here is right here, x over y. X divided by y. X, y, whatever. And it is being raised to the z power. So a fraction, a quotient being raised to a power, and z is our power. What does it say we should do?
Raise the numerator to that power in the denominator.
Yeah, it says it right there in italics. Give the z to the numerator and to the denominator. So what are we going to do with 2/3?
Multiply it by, like, 2 to the 4th power and 3 to the 4th.
We're going to give the 4th power to the numerator 2. We're going to give the 4th power to the numerator 3. And now can we subtract?
This is division.
I know, I thought that's what you did, is subtract exponents in division. Why not? Oh, they're not the same base. Good catch. They are not the same base. 2 is not the same base as 3. So this is as good as this one gets as far as simplifying goes until you say, okay, what is 2 to the 4th power? What is 3 to the 4th power? And then go from there. Okay? So these are all things they assumed you knew before you got to lesson 6.1. Did you know?
Yes.
A lot.
Quite a few of them.
Yeah.
I'm going to name them by what they are, and you have to be able to say, and you got to be able to work with these. Okay? So, questions?